So this is a talk about getting started with Spring for Apache Hadoop. And my name is Thomas Risberg. I've been involved with Spring for a little over 10 years. I'm now leading the Spring for Apache Hadoop project. I co-author a couple of the Spring data and the Spring framework books. And I originally worked on the JDBC framework, the JDBC template, and all the classes around there. That's where I picked up Spring from. I worked a lot with JDBC, and I thought Rod Johnson had a good solution for working with that in the JDBC template. So that's when I joined the Spring project. And this talk is going to be all about Hadoop and Spring, how to work with Hadoop from a Spring application perspective. So a lot of organizations these days are evaluating Hadoop as a data lake or some other big data solution. So I'm assuming you have some familiarity with Hadoop. How many of you went to the talk before this on Hadoop with Roman? Okay, that's a good part of you. And how many of you did actually attend the Hadoop training the first couple of days? Okay, that's good. And so probably what I'm saying here will be a little bit of repeat if you took the training, but I'm basically covering the Spring side of things, so I'm not going to cover much about Hadoop itself. And I have a bunch of examples up on GitHub repo. So if you search for Spring Hadoop, Spring 1 2GX, on GitHub, you'll come up with a repo where I have all the source code for this. And I also have instructions for setting up a basic Hadoop cluster in a virtual machine so you can run it on your laptop. And that's what I'll be using for my demos here today. So when you start working with Hadoop as a Spring developer, you hit a couple of challenges right away. The out-of-box programming model is not what we're used to as Spring developers. It's a lot more low-level. Sometimes it feels like you're either back in JDBC or even EJB style programming, and they checked exceptions and all kinds of things. And there are different versions of the MapReduce APIs. And there's so many different projects in the ecosystem that they all use slightly different styles to interact with them. And it's also very hard to get all the versions right. And then there's so many distributions of Hadoop out there. To get all those versions in sync is a major challenge. So that's why we came up with this Spring for Apache Hadoop project, to provide a Spring-centric solution to some of these problems that we were seeing. So it's an extension to Spring, and it uses a lot of Spring Batch under the covers. And it also integrates well with Spring integration. And the point is, we want to build a robust pipeline where you move data from the input source to wherever you want to process it and to your output, and make that sort of a repeatable process rather than using shell scripts and things change all the time. And pretty much what we used to when we build like a Spring Batch application. So it gets controlled by the Spring application context. We'll see some examples of that. But before we get into any of the more advanced things, I just want to see how easy is it actually to connect to my Hadoop cluster and run some kind of process against it. So I put together a little script, and I need Spring Boot. I need the URL from where my name node is. And I need a file system shell, which is what the Spring for Apache Hadoop project provides, which is basically the Hadoop comes with a command line utility where you can run just basic commands for the file system. So we have an abstraction over that we can use programmatically. So we can get directory listings, we can look for files, we can delete files, etc. So I have a little directory here called hello. Oh, I'm in the wrong directory. So this is the GitHub project I have up there. I have a bunch of different little examples in there. And I also have a data file that's in the data directory. So we'll be using some of them for the examples. But first, let's go to the simple, hello, Groovy. So I put together a quick app in Groovy. Can you all see that? Is that big enough? So basically what we do here, we use the Groovy grab command to pull down the Spring Framework data, Spring Data Hadoop dependency. And I'm using Hadoop 2.4.1 on my cluster, so I need to specify the version there. And I'm using the 202 release. And I use the file status, which is part of Hadoop's API. And I use the FS shell, which gives me the command line shell commands in a programmatic manner. So I boot this up and I auto-wire my shell. And that's what I create down here in the bean. And first I create a Hadoop configuration. I set the name node's URL here, and that's the only configuration I really need for this example. So then here in the run method, I just get the file status from the shell for a certain directory. Here it's the root directory. And then I just loop through all the files in there and just print out the owner, the group, and the name of the file. So when I run this, I just use Spring Boot. And right now I have the 1.14 release installed. I haven't really upgraded to the latest one, but it works. So I just run spring run app.groovy. And we should see the Spring Boot screen come up, and it's now connecting to my data, to the data in Hadoop. And it takes a little while because it has to wake up the VM. So that's my directory listing for the root directory. So it doesn't take a whole lot of code to actually get something working. It's when you get into more of the MapReduce and all the workflows that it gets a little trickier. Now this is good if you want to use Groovy. But let's say you're a Java developer and you just want to write the same thing in Java. So this is basically the same code. All I have to do is just add a few more imports because Boot does a lot of automatic importing of the common annotations. So here I actually have to explicitly import all this stuff. Other than that, it's pretty much the same application. It does create an FS shell that gets returned as a bean. And I print out the same information. And now I can't just run this, I actually have to build it. So I need a POM. So I'm using Maven here. And I'm actually using the Spring IO platform as the parent. And I'm using the 101 release. And that gives me all the dependencies and the versioning of the dependencies that actually work together. And I can override them, so I can set some properties, because I'm actually overriding the Hadoop version. I want the specific one for Hadoop 2.4.1. And I also specifying that's the Hadoop version I'm using. And yeah, I can override any other versions in the platform if I need to. And I have dependencies declared as a boot, the auto configuration, the logging. I use the log4j because a lot of Hadoop libraries have log4j with them. So if I use logback, I get all kinds of exceptions. Sometimes it gets trickier to manage the dependencies there. So I tend to use log4j. And then I depend on the Spring Data Hadoop project. It's in Hello Hadoop, so I just do Maven clean package to build it. And then I can run it with a Java jar. And I should see basically the same output as we did from the Groovy script. So that's basically the hello world of Spring Hadoop. Yes? The other question was, there's a Spring Boot starter. I'm not using any of the starters. You can, but I'm using the Spring IO for the dependency management. And I didn't use the starters. I just pick whatever pieces of boot that I want to include. But you can build with the boot starters as well. And you can also depend on the Spring Boot as the parent to get the dependency management that way. So it's just a different way of doing it. But it's, yes. There's a different parent POM. I think the Spring IO POM depends on the Spring Boot POM. So they're sort of interconnected, but I'm using just the platform one. So then these are just the slides. I show you what I did here. So we can just skip past this. We already went through this. So if you download the slides, you have the examples there. So you can just take a look at it. So let's take a look at the features that we provide in Spring for Apache Hadoop. Like you saw, we have a configuration option. And the idea is we want to be able to parameterize the Hadoop configuration. So if you use Spring, you're used to using property placeholders and features like that. And that works very well with the Spring for Hadoop project as well. And we also have support for running MapReduce jobs, both just regular MapReduce or streaming or some of the Hadoop tools, or you can run Hadoop. Hadoop has a feature where you can run Hadoop jar and just run a Java jar as part of that. You can do that with Spring for Apache Hadoop as well. You can define the things that Hadoop has a distributed cache. So with the Spring Hadoop configuration, you can actually define how that's going to be used for your app. And you can use environment profiles, like that's a typical Spring feature. If you run your test and you want to change it over to the production cluster, you can have a different profile for that. And we have support for working with Hive, Pig, and HBase as well. And we also have features where you can, for writing to HDFS to make that easier, where we give you ways to partition your data, either based on date or customer or whatever you want to partition on. And we support several data formats and compressions. And this talk, we don't have 5 hours or 10 hours that we would need to cover everything here. So I'm not going to show you some of these things I will show you, some of the things I will not show you. So we're not going to look at the writing to HDFS today, and we're not going to look at any of the yarn support that we have as either. But there's a talk after lunch with Janne, who's sitting over there. He's going to talk about all the yarn stuff that we have now in Spring for Apache Hadoop. So the aim is to increase the developer productivity. We did that earlier with for the web development, for the JDBC development, that people got more productive. So we're trying to do the same thing for Hadoop. And to create like real Spring applications with application context, and you configure everything and you can run it, you can schedule it, instead of running some scripts and sort of depend on that things are in the right place at the right time when you run your script. And we support scripting inside the application context. So if you want to copy a file, you can write a little Groovy script or a JavaScript script to copy files using the file system commands that we saw earlier. We have template classes for working with Pig, Hive, and HBase. We have classes where you can run smaller workflows with MapReduce, Pig, and Hive. And we have, for Spring Batch, we have tasklets for MapReduce, Pig, and Hive. So you can have your MapReduce jobs be part of your batch workflow. So the range of applications are pretty wide. Like you have the ingest where you can stream in events, you can read from JDBC, or you can write to JDBC too. So NoSQL, you have files, and we have the jobs for orchestration. We pretty much rely on Spring Batch. And export HDFS to JDBC, NoSQL. And a lot of features that we use in Spring for Apache Hadoop is based on batch and Spring integration features, that they all kind of work together. And Spring XD now takes this to the next level, where you actually provide a runtime, where we provide Spring integration, Spring Batch, and Spring for Apache Hadoop as part of that runtime. So you can build batch jobs, you can build streams, and you can run them in XD. And actually for this talk, I had the batch examples. I'm actually going to run them inside XD as an XD job. So Spring for Apache Hadoop started by Dave Sire and Kostin Lau back in 2011. So the first 1.0 GA release was in February 2013. So it's a fairly young project, but it's moving along. And the current version is 2.02. And the 1.0 version that we now have is 1.1.0. And the 1 series supports Hadoop version 1 and 2 up to 2.2.0. So we don't plan on moving that further to the later Hadoop releases. That support is in 2.0 series, and that supports backwards to 1.21, and up to 2.5 will be the next 2.03 will actually support 2.5. And we're working on new features. We're putting that in 2.1. We just had a milestone 1 of that the other day. And that's only for Hadoop version 2 support. So no backwards compatibility with Hadoop 1. So if you have Hadoop 1, you need to use 2.02 or 1.1.0. So versions. It's always complicated to get it going. Everything I use for today is Hadoop version 2 APIs. I use Hadoop version 2.4.1 as my cluster. And like I've said earlier, 2.0.2 is the release, and Hive is 0.13.1 is what I'm running for the examples here, Hive Server 2. And I'm using Spring XD, their 1.0 release version. Do you have a question?
Yeah, so I'm trying to follow along on GitHub.
Okay.
I only see 3 files up there. I don't see the project there. I'm under T Risberg.
No, you should go under the Spring 1 2GX-2014. There's a whole set of conference repositories there. So to complicate things, there are different distributions out there. It's Cloudera, HortonWorks, Pivotal, and there are others. The ones we support are Apache, Cloudera, HortonWorks, and Pivotal. And we try to keep up with the latest version that come out for all these distributions. So we have what we call a flavor of the release. Each release we run with a different set of dependencies to generate the POM file. So you have so if you use, like here, we specify Hadoop 2.4 as the flavor for this release. So there's a plain one, which is the default Hadoop 2.2. And then we have Hadoop 2.4 for 2.4.1. And if you want the older Hadoop 1.2.1 version, you would have to specify Hadoop 1.2. And if you use Cloudera, you just put CDH5 or CDH4 back there. Or HortonWorks, that's whatever version of HortonWorks you're using, HTTP 2.1, 2.0, or 1.3. And same thing for Pivotal, either PhD1, which is the 1.1 version, and the 2.0, which is the most recent one. So the building blocks we need some kind of configuration. I tend to use the XML namespace that comes with Spring for Apache Hadoop. So wrong button. So do Hadoop configuration, and then you just specify your Hadoop configuration properties there. Like a lot of Hadoop projects assume that you have all the Hadoop configuration files on your class path, like the core site XML, the yarn site XML, all these ones. Like we typically don't want to have those on the class path because then it makes your app less portable. So we tend to just put in what we absolutely need here and skip having the core site or the yarn site XML on the class path. And I can do this in a bean style, although we don't have any explicit support for that other than for yarn. So Janne will be showing you the yarn things later on, but for regular Hadoop configuration, we don't have any extra support for Java configuration. Now we're thinking about doing that for the next milestone or the milestone after that in the 2.1 series. And if you have suggestions, we're more than welcoming either Jira's or GitHub issues if you have ideas for what you want to see supported. And so most of the examples I'll be using the XML style for configuring the jobs. So here's a tweet where we're getting in a tweet stream. I did a tweet search on Hadoop and captured that in a file. And so each tweet is a one-line JSON string in a text file. So for my tweet count job, I want to count the hashtags in the tweet, I guess. So I put the input path here. HDFS input path is a property placeholder. Same for the output path. And I need to provide the jar file that for my example to actually, because this is going to run on the Hadoop cluster, so we actually have to upload the jar file there. So I have this MapReduce jar that I've written myself. It's not an example, it's one of my examples. So I need to compile that and make that a dependency of this app. I have my tweet count mapper and in some reducer, which is in this jar. And then I have a job runner to actually take this configuration and actually run it. And I can schedule this, so I can run it on startup whenever the app starts up. And I can also specify actions to happen before the job runs. So I might want to copy files. I might want to set up my environment. I might want to do something after the job is done. And then, so I need to provide these placeholders, some values. So I have a application properties file where I specify actually where my input path and output path is coming from. So the scripts, I can use Groovy, I can use JavaScript. That's typically the ones I think we support anything that's, I think it's JSR 232 scripting. So whatever is supported there. But the examples I have are in Groovy. So here I just test for the input directory. If it's not there, I create it and I copy the local file in there and set the permissions on it. And I also see is the output directory there. My MapReduce jobs will not run if the output directory exists. It'll throw an exception. So I just remove that output directory. And here's the local file that I'm using for this example. So I just find the user directory and the local file, string them together, and that's what this script, the Groovy script that gets started up here actually gets an FSH instance of the file system shell. So you can just use the FSH variable to access that and run all the shell commands there. So this is what the input file looks like. This is formatted. It's actually one long string and one line. So in the tweets, there is an entities entry with hashtags. And these are the two hashtags that were in this tweet. So those are the ones we will be counting. So this is my mapper. This is standard Hadoop mapper. This has no spring in it. So I get the text value in. I do create a JSON mapper. And I pull out the entities. And for each entity, I get the hashtags. And for each hashtag, I loop over this and write the hashtag and the count of 1 for each time I come across a hashtag. So then the reducer will actually take this and reduce it up and just add these counts up. And that gives me the output. So this is standard Hadoop MapReduce. Nothing to do with Spring really, other than we'll be using it in our examples. So to run this, I can create a little boot app. And basically all I do is pull in the application context that I've defined and run it. And since the job was defined to kick off on startup, I don't have to do anything else here. So what's the app context look like? Well, we have the configuration. I need to provide the URL for where the name node is. I need to tell him where the resource manager is. I need to decide that, okay, I'm running a yarn MapReduce job. And I need to know where the job history server is, so I can actually make sure that the job completed. So the input path, we already went over some of this. The jar file that I'm using, the mapper, the reducer, and the runner to kick the whole thing off on startup. So I'm not doing any copying here of files and things. I have other examples for that. One thing that tweets MapReduce, I want to, since I have to specify the actual file name here, I use the dependency plugin to remove the version. So if I update my MapReduce logic here, I get a different jar, maybe 0.2 instead of 0.1. I just strip out the versions. I don't have to change my application context. So this is a simple MapReduce. Just have a POM and the source files. And if you look on this is the GitHub repo. Each example has a quick README for how to actually build it and run it. So I do actually need to copy the data since this is not built into this sample. Luckily I have Spring XD running, so I have the Spring XD shell up here, so I can actually run some Hadoop commands from here. I have to define it, that's right. Forgot this part. So I actually have to tell XD where is my Hadoop name node. And now I can actually create a directory. Should be able to copy my file up. So now we should be all set to run this MapReduce job. And since the boot app, we just started with the jar option. So actually, you see it's running job and the job ID. We can look in the so this was actually the job, it's still running. I think it's finished. Yep. So it did succeed. So did we get any output? We did get something there, so let's see what's there. So there's our hashtag. Here's the count. Has another hashtag, Hadoop. That's what I actually searched on for the finding the Twitter's tweets that we stored in the file. So that's probably why that's so high. And there's another Hadoop. So you got 18 of those. So that was very simple MapReduce, nothing fancy. Now can we do the same thing in Hive? And for Hive example, I just want to see all the people who tweeted, and that's part of my file, who is the one with the most followers. And I just want the top 10 based on number of followers. So in boot app looks pretty much the same. I can specify a placeholder for where the tweets come from. And I'm using Hive 2. So I use a JDBC template to access Hive. Hive 2 server now has, it's all JDBC. So it's pretty much like any other database. You just give them a URL for the JDBC connections to Hive and you run your SQL right from there. So if you're familiar with the JDBC template, that's another good skill to have for the Hadoop development now. So here I'm just saying, okay, I'm just printing out, I'm running using the input from here. And then I have my DDL to create the table if it doesn't exist. And the location is where the data has to be in HDFS already. So I'm just linking Hive, pointing him to where the data is in HDFS. And then I can run my select, and I use a getJSON object function that's part of Hive to pull out the screen name and the followers count. And then I order by the followers and limit it to 10. And that gives me back a result list, like typical Spring JDBC. You query for a list, and you get back a list that has a map with a string and an object. In this case, it will be the string will be the screen name, and the object will be the count for how many followers they have. So then I can just loop over that and print out the results of the query. So let's just run this, see what happens. So this is a simple Hive example. Let me just make sure I build it first. So now in my configuration, I actually specify the inputs as tweets input data. I think I forgot to copy the file, so we probably won't get anything there. So let me actually follow my instructions here. Simple Hive. I think I actually have the data up there already. Let's see what happened. Still running. Just finished. Okay, so we actually got the two jobs running here. So you can see Hive actually submits two MapReduce jobs for this query, stage 1 and stage 2. And they both succeeded. And here's actually the output. So for this file, IBM Analytics has 20,000 followers. So they're the top guy here. So I don't know who these other screen names are, but we did get some output. So if you really want to build something that's more robust, we do need to make sure that files are up there. Like I almost forgot to copy the data file up there. You don't want to have operations worry about that, so you put that in your application context. So using the scripting support that we talked about a little earlier. So in the small workflow, which is the next example, we're actually getting these files every day. And they'll be in a directory with a date attached to the file name, so we can know what date they're coming from. So we need to copy them into HDFS and then run the same MapReduce job on that file. Let's see how we're doing on time. We probably have enough time. So the actual application, again, is just loading up an application context. We're using the import resource here. And these are my properties for this boot application. So I have all the Spring Hadoop FSURI with the placeholders. And I actually override these when I write my app, when I run my app. So I can So this is actually where I set environment variables. Now Spring Boot will pick these up and translate these and make these dots. So these will actually be properties that can be used in a property placeholder. And so these values, this is my host for where my cluster is. These will actually override what I have in the configuration file, which says localhost. And then I just specify the local file that I need to copy up, and the input path and the output path where I want the results to go. And since I have a script here that does the preparation to remove the output directory, I don't have to worry about that right now. And I know the input directory will be there because I have that in the script too. So the instructions to run are a little simpler. Just clean package and run it. I'm in the wrong directory. Okay. So this should now copy the files up there and again run a MapReduce job. And I think I have an output step that actually takes the data in the results file and actually displays it on the screen here. Yeah, it just finds the results text and prints it out. So we got some output from here, so just so we can see it on the screen. So now we got a different counts because we used a different file. But these are all hashtags and the count for the hashtag. So this is all great if you have very tiny things to work on, just one file, one MapReduce job, and not much more. Now if you want to do something bigger, where you have multiple files, multiple jobs, we really need to look at a bigger workflow solution, which is where the other Spring projects come in, like Spring Batch, Spring Integration, Spring Framework is the basis for all of this. Spring Boot we use to run everything. And Spring XD kind of takes all of this and puts it into a runtime that you can use to run these jobs. So the Batch framework is the basis for JSR 352. It's been around for a long time before that. It was collaboration with Accenture. Like Wayne probably remembers a few issues around that. And we have a lot of different features in Spring Batch. Some of them we use for Spring for Hadoop, but not all of it. But they're parsers, mappers, readers, writers. Batch does a lot of retries. On failures, you can specify what exceptions you want to retry on. You can specify how many times you want to retry. And it does support both synchronous and async processing. You can run things in parallel. You can skip records. If they're bad records, you can have them put somewhere else. And so you can track the jobs because it has this database where it keeps log of all the steps and all the jobs that it's actually running. So it's a pretty complete package for running your batch jobs. So Spring XD uses Spring Batch, but it does package the jobs a little differently than what Spring Batch does. So it's Spring XD in the directory, if you install Spring XD, there's a modules directory under there. And under there is a job directory where you define all your jobs. So you give it a name. You define a config directory where you put your XML file, which is basically an application context. And you have a lib directory where all the jars that you need for running the job. Just the jars that you're providing. Spring XD has a lot of jars already built into the runtime, so you should not put those jars in there, just the extra stuff. So this is my little MapReduce job. I put that in here. And this is the actual batch job that I've been writing. So that goes in there as well. So the question is, how do I get this stuff in there? I can manually copy it, that's cumbersome. So I can write a little, add some to my POM to actually do this for me. So again, I'm just depending on the I/O platform parent. I override some properties because Guava that's in the I/O platform doesn't work well with Hadoop, so I actually have to use a specific version. 16.0.1 seems to work well, so that's what I'm using. I need to know where XD is, because that's where my POM will copy the jar files at the end. I give them a name from the job. This job is called tweets hashtags. So as you can guess, it's actually counting the hashtags that are used in this Twitter file. Same kind of dependencies. I actually depend on my tweets MapReduce, which is a separate project. So I need to define the version I'm using here. Well, that's the one I want to get rid of. So I'll show you how I did that. So I use the dependency plugin, and it has an option to strip versions. So I copy all the dependencies into a specific location, which I just call in my build directory, I just call that xdlib. And I strip out the versions, and I exclude any transitive dependencies, because I only want my little MapReduce jar. If I didn't say that, I would get all the Hadoop stuff and everything that Hadoop depends on, and that's pretty much half the universe. And then I use the assembly plugin to actually package this up, put it in the Spring XD home directory under the job, modules job. And since I forget to specify the XD home, most of the time I have a enforcer plugin to make sure that that environment variable is actually there, or it will throw a failure. So with the assembly plugin, I actually need an assembly XML definition. So I package up anything that's an XML file into the modules job. And I package up the xdlib jars into a lib directory. Oh, XD home. So So these are the jobs that are already in there. And if you look in Spring XD, it should actually list all the modules you have. So we have file JDBC. These are the ones that come with XD, pre-packaged. Go into batch MapReduce. If I do Maven clean install, this should actually build a project, run the assembly and all the copying the dependencies, and pull that all up to XD. If I refresh that, I should actually see my job here now, tweets hashtags. I can take a look at it, see what the XML looks like. This is actually my application context. So how do I run this now? We should already have data in the input. So let me. Oops. Oops. That's not good. All right. Try again. So we already have an input file in our data there, so that's good. So I should be able to run this. So I created the job, so we should now see it under the deployments. There should be a job here. I can launch, this is from a previous run, the workflow one, but hashtags, so I can actually launch it from here, specifying the parameters, so I can launch it from the command line. Either way. And then we should see something executing here. It failed. Probably the output directory. Yeah, it already exists. So that's the problem when you're not doing all this scripting to create and to delete directories. You forget you have the directory there. So let's look at the next example, which actually solves this problem, which is the whole batch workflow. So this is my configuration file. I have a property placeholder because I'm running both a MapReduce and a Hive job in this example. So I need to have my Hive properties pulled in. I need my Hadoop configuration. This is the same as we've been doing all along for all the other examples. And to access any of the job parameters I'll be passing in, I need to have the step scope enabled. That way each step has access to the job parameters specified for the step, actually for the step parameters. And since I use the same parameters several places, I got tired of copy and pasting it all over the place, so I created a little map where I actually do the calculations up front, and then I can reuse those in my definitions later on. For the input path, I don't want to have to specify like the root part of the path. I just want to, or if I don't specify an input path, I actually want a default to go to tweets input. And for the date, I actually specify the file that has appended the date of the file was created. So I just want to pull out the actual date and use that as my date parameter. And same for the output path. I defaulted to tweets output. And the Hive path, I have a tweets Hive. And these are all HDFS directories that I have created. So then the actual batch job consists of several steps. One is to just initialize Hive, which is a scripting tasklet to actually create the Hive setup. Actually, that's the second step, initializing the Hive. The first step is to run the copy of the input file, which is a script tasklet. And then I do the calculations, which is actually do the MapReduce job and the Hive job. They don't depend on each other, so I can actually run them in parallel. So I have a parallel flow here. And then at the end, I export the results of the Hive query out to a relational database. So the script tasklet is pretty much what we saw earlier. It just copies the input file. The one that's different is the Hive initializer, which actually is a JDBC job that uses a Hive data source. And the class I'm using for this is a Hive initializer tasklet that I put together. Where is that? It's down here. So it basically runs this SQL script to drop the table and create it based on whatever the location of the data is. And for batch, I need a mapper. So when I read the Hive data, and actually need to, this is for the output. So my output actually reads a Hive table, which is they're delimited by hex 01. So I need to split the input line on that and then create the map. And then I just print the output map and put that in a JDBC relational database. Yeah.
So the screen integration, you have complete XML support with STS. Do you have also that one? Screen integration, when you actually package stuff, you have complete XML, you have the complete graph support.
Oh yeah, it should have. I never used it, but yeah, it's built in here. Let me see if I batch graph. So it's right there. So the import initializing Hive calculate, which is a parallel step, and then the export and the job ends. So we did install it, and you'll see if it's here. So we have a tweets workflow module now defined. Let's see if that deployed cleanly. Yeah, that's why it doesn't work from the command line, does it? Let's try here. There we go. I should look for that message. I thought it was strange. All right, so we have the workflow. It's deployed. I can launch it from here, or I can launch it two different ways. I can either launch it just passing in job parameters, or I can launch it using a stream and then copying files into a directory where XD will look at the file. So let's do this. Create the stream. So now I have that list, that stream, and actually looking for a local file in a directory. Which is this directory. So if I drop a file in there, something should happen. Yeah, that's the local directory. So XD is watching that local directory with using this stream. I don't think so. Do you know, Janne? Can we watch an HDFS directory somehow with a resource? I don't think so, no. Let's drop a file in here. See if something happened. All right, something started. So we can see the local file that actually I copied in there is, the file name is actually showing up there as a job parameter. And we have the import completed, the initializing the Hive is completed. Now the two parallel steps are running. And at some point we should see the everything. So that was the Hive job is still running, finished. So we go back here and we might see everything done, complete. Yep, the export completed. We got 10 writes, which is what I expected, the top 10. And if we look at the database, we should actually be able to see the exported data. Check all the Twitter influencers and the data. Yeah, so that's the input, the output from that job is here. So what are we using this for? Well, we can ingest and export data. We'll look at some of the output thing I used for this example a little later if we have time. So you can read log files, you can transfer and write data to HDFS for these batch jobs. So you can read data from HDFS, write JDBC, HBase, MongoDB, whatever you're using, all the Spring Data projects, whatever you're accessing. And this is good for orchestrating your Hadoop-based workflows. And the nice feature with Spring Batch is it doesn't all have to be Hadoop. I mean, you have a lot of other jobs you want to run too. So you can integrate those with the Spring. For Apache Hadoop jobs you have. So it doesn't, you don't have two separate systems for different types of jobs. It's all integrated into one. And like we see, the steps can be Hadoop, MapReduce, or Hive. I also have support for Pig. I don't show you Pig today, but basically the same support that we have for Hive, we have for Pig. We looked at the configurations. So exporting HDFS to JDBC, we need a reader. And then that actually, for this one, I actually read from a Hive table. So I used a slightly different approach there. Let me just pull up the... So the export step was actually a HDFS reader and a JDBC writer. So the writer is just a simple JDBC insert into a file. It's right here. Here's your JDBC writer. Just insert into Twitter influencers, the username and the followers, which was I used the Hive data mapper to pull those values out from what I read from the Hive table. So I'm actually just reading the file. I'm not actually using Hive to access it. I'm just reading the actual output file from Hive, since that's a flat file. So let's change approach it a little bit and look at what we're looking at for the future. Like I already mentioned, that we have a 2.1 where we're doing any new developments, which is Hadoop 2 only. And most of the new features are new yarn support that we're providing. And we're also improving the support for HDFS writing, especially for the data set where we use Avro, Parquet. We're thinking about writing directly to Hawk. A lot of these are just plans so far. And 2.0 and 1.1 is basically in maintenance mode, and we'll keep up with some new versions, but it's not going to be a whole lot of new development there. And the resources for my talk here, all the links, the demo source, which is on GitHub. I have installing Hadoop. I wrote together all the steps I needed to set up a basic virtual machine to run Hadoop cluster in it, a single node, using both Hadoop and HDFS, Yarn, and Hive. So if you need to get a basic VM, it takes about 2 gigs, preferably 4 gigs to run it on it. So you can actually run it on a laptop that doesn't have a whole lot of memory. And questions, there's a tag on Stack Overflow, Spring Data Hadoop. You can follow us on Twitter. Spring Source Dev on YouTube has a lot of videos, so if you want to learn more. So when I was developing these little apps, I came across a couple of things here. And And one of them I already talked about to get rid of the version number. Like if you actually have to put a jar, name of a jar file in your config file, you don't want to have the version in there. So I did get rid of that. And to create an XD batch module, we covered a bit of that. You need to use something to copy all the files into the right place. I use the assembly plugin to create the structure that XD requires for the jobs. And to use the job parameters instead of repeating that over and over again, because I want to reuse these. I put them in a map, I give them a key, and I can just pull out the map in my spell expression. So if I want the input path, instead of specifying this whole thing here several times, I just pull out the map, already calculated value. Makes this more concise and easier to manage and maintain. And I also use that inside the Hive definition. So right in the SQL I create for Hive, I can actually pull things out of there as long as this is in the application context. And there's no JDBC tasklet, which is something I've been talking to the batch guys that we probably want to put something into batch. Like we have tasklets for Hive, we have tasklets for Pig. But JDBC is, we could put it in the Hadoop project, but it's more of a general purpose thing. You could use it with any kind of SQL for any database. So we do want to have a JDBC tasklet. Dave Sire had an example up on from several years ago, so I copied that. One of our field engineers, Christian Zolov, has copied Dave's and improved it, and he's using that. But for this example, I actually have another implementation that I just use here, and it basically just runs a SQL statement against a JDBC source, data source. So let's not forget Yarn. There's a dedicated talk, I haven't covered Yarn at all today, where you can go see painless build and deploy for Yarn applications with Spring. So 12:45 after lunch. And I did put together a Yarn example just to show you what to expect a little bit. So I have a Hello Yarn app, which is basically a Spring Boot app. And I have a Yarn component annotation on this. So when this runs the Spring Yarn boot, we'll see that this should be run. And I'm on container start, it will actually execute this method, and I can actually write the log message. And then I should be able to pick that up from the Yarn logs if I'm lucky, if I can find them, because they're sometimes hard to find. And so I'm not going to cover this in detail because Jana is going to cover this a lot more later this afternoon. I just want to see if I can get it to run. So as usual, I have a Spring Boot create a jar for me. I run that. And it's now submitting the Yarn job. And I think I see an ID here somewhere. So that's the ID. See if I can find it in my... So this is the job that just ran. And if I go to my cluster, I should be able to find the log file. I think that was the one. So container, which one has more data? This one. So I should find a hello yarn in here somewhere. Okay, here it is. So this job actually got submitted to Yarn. It was allocated in container, it executed it, and I can find the log file and see the output. So, any questions? Yes?
Early on, you were showing this code, and I think it was before the integration with Hive, but you used the standard Jackson JSON parser to bring in your data. And I was curious if doesn't Hive come with its own JSON serialized, deserialized libraries? And were those, is that just a choice that you made? Is it Jackson, or I guess if you're integrated with Hive, you need a parser?
Yeah, Hive has two ways of getting at the JSON data. So the one I used, and there is another one, like you say. And so the question was, for Hive, I show one way of getting at the JSON data. And there is another way, and there's yes, I forget what the name of it is. I've used it before, and it's just a different way. You just get a slightly different way of outputting it. This one, to me, is easier to read for the simple query. The other one, I had an example, I think last year, my Hive example, I actually used the other style. But either one, whatever is.
Yeah, there seemed to be a whole list of them. I don't know if your experience was that.
No, I don't really write a whole lot of Hive JSON queries, but I just mostly, the ones I've been writing are mostly demo ones. But I think there are also third-party ones, and you can write your own serializer, deserializer. So there are a lot of options. I just picked one that came with Hive because it was simpler to set up. Yes?
You can also use HBase for Hive instead of using Hive directly on HDFS, because that's supported with the Hive integration through Spring Hadoop.
No, but I'm not familiar with it. I've never used that. The question was, there's a HBase for Hive way, so you can actually interact with HBase, right? Using HBase commands to get to Hive data.
The Hive JDBC driver, for example, can read data directly from HBase.
Oh, the JDBC driver can write. Okay. Well, in that case, it would just be JDBC support that you would be using.
What has to change in your password and the JDBC part?
Well, whatever the URL would have to change, right? That's pretty much it. And you would have to make sure that the SQL you write would. Right. Yeah, okay. Yeah, I'm not familiar with that, so I have never used that. Any other questions? Or? Yes?
Are there plans to integrate Spring with Spark, Apache Spark?
We talked about it, and we don't have any firm plans. The question was, do we have plans to integrate Spring for Apache Hadoop with Spark? And we're more than welcoming suggestions for what type of integration you would like to see. I mean, I can see a Spark tasklet where you can run a Spark job in batch. I'm pretty sure that would come at some point. I'm not sure what other type of integration. Maybe just run a Spark query from Spring for Apache Hadoop. Yes, I think you'll see something coming in the next year or so in that line, but we don't have any firm plans. I can't really tell you what we will be implementing. But feel free to open the Jira and suggest things that you need to see. All right, well, thanks for coming and sitting through Hadoop. It's always a challenge.